Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 15, 2025, just 2 days ago. It lays out a full post-training recipe that gives a 30 billion parameter model long context reasoning strong enough to match GPT-5 and Gemini 2.5 Pro on tough benchmarks, while beating its own baseline by 9.90 points and adding 9.48 points on ultra-long tasks. The paper is titled QwenLong-L1.5 Post-Training Recipe for Long Context Reasoning and Memory Management. And as we will see later, the implications for how we train models to handle million token inputs are pretty exciting. Also, the authors shared everything on GitHub. You'll find the full QwenLong-L1.5 post-training recipe, code and configs for long context RL training, the earlier QwenLong-L1 framework, plus the Spell self-play RL implementation. There are scripts, model checkpoints or links, and document understanding examples to help you reproduce and extend their results. On that Hugging Face page, you'll find the 30 billion parameter QwenLong-L 1.5 model weights, plus transformer loading code and prompts for long document question answering and reasoning. Figure 1 shows that QwenLong-L 1.5 jumps well ahead of its base model and most competitors on long context reasoning. The striped blue bars dominate almost every benchmark category, which means the post-training recipe consistently boosts accuracy. The left side covers individual tasks like MRCR and Corpus QA, while the rightmost group summarizes the overall average, where QwenLong-L 1.5 nearly matches Gemini 2.5 Pro. Figure 2 explains how the memory agent turns a huge document into a step-by-step reasoning process so the model can handle ultra-long contexts. The left side takes a user query and decomposes it into a core question plus formatting instructions, while splitting the long document into chunks. The center pre-process block lists these chunks explicitly, which are then fed into the large memory pipeline on the right. Inside that pipeline, each chunk updates a compact memory state and a navigational plan, so the model gradually folds the whole document into a small, useful summary before generating the final response. Table 1 shows that the reinforcement learning training data grew from a small, narrow set into a much larger and richer corpus. The left side column describes QwenLong-L1, which used about 1,600 samples from just a couple of domains and shorter inputs. The right side column contrasts this with QwenLong-L 1.5, which scales to roughly 14,000 samples, many more domains, and far longer documents. The expanded question types now span hypothetical scenarios, temporal and causal reasoning, long and context learning, and dialogue-style tasks, so the reinforcement learning signal covers many more challenging behaviors. Figure 6 summarizes how the authors gradually turn the base QN330 billion thinking model into QwenLong-L 1.5 with both long context and memory skills. The top row shows 3 stages of full context reinforcement learning, where the model first learns on 32,000 token inputs, then 60,000, then 120,000, so the rollout budget grows with each stage. The middle right block introduces a separate memory reinforcement learning expert that sees chunked 128,000 token inputs and learns how to manage a compact memory state. The lower path then merges this memory expert back into the full context model using the SCE algorithm, followed by a fourth full context stage that consolidates everything into the final system. Table 7 makes the central point that a 30 billion parameter QwenLong-L 1.5 can match or beat much larger long context reasoning systems. The top block compares flagship reasoning models, where Gemini 2.5 Pro and GPT-5 lead but set the scale. The middle block lists lightweight models, which mostly sit in the low to mid-60s on average. The shaded bottom rows show QwenLong-L 1.5 reaching about 72 on average and nearly 83 on the MRCR benchmark, with blue deltas highlighting its gains over the QN330 billion thinking baseline. Table 9 shows how these models cope once contexts stretch far beyond 128,000 tokens. The top block reports full context inference, where Gemini 2.5 Pro still leads on MRCR and Corpus QA, but cannot run at 4 million tokens. The lower memory agent framework block is the key comparison, because it lists systems that actually operate at those ultra-long lengths. QwenLong-L 1.5 roughly doubles its own baseline on MRCR around the million token range, so the memory agent training clearly helps it retain useful information. On the hardest 4 million token Corpus QA split, QwenLong-L 1.5 reaches about 14 points, ahead of both the earlier QN3 memory agent and the prior MEM agent model. Alright, to wrap up, QwenLong-L1.5 shows that smarter post-training, not just bigger models, can deliver near-flagship long-context reasoning and even handle million-token inputs with a learned memory agent. The broader message is that long-range reasoning is becoming a practical, open capability. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.